welcome you all to this section. We are in Unit 4 on algebraic thinking, sequence and series. In this section, we shall look at what sequence and series are, and we shall also talk about some types of sequences and solve some related questions on that. So we are starting with the definition of sequence and series. Now before that, let's study each of the following numbers and determine the next 4 terms. So let's look at this sequence. We have 2, 4, 6, 8. When you study this sequence, you can see that before you can get the next term, you need to add some constant to it. So for example, to get the value of 4, we added 2. To get 6, we added 2 to 4. And to get 8, we added 2 to 6. So it means that to get the next term, you have to add 2 to 8. So by adding 2, we will get 10, add another 2, 12, add another 2, 14, add another 2, 16. Therefore, we are saying that this sequence has a common difference, and the common difference is 2. Now let's come to the second one. We have 2, 5, 8. You can see that if I add 3 to 8, I'll get 11. Add 3 to 8, 14. So we keep adding 3 because we added 3 to 2 to get 5. Added 3 to 5 to get 8. So this also has a common difference of 3. Now the last sequence, you can see that 1. Then from 1 we are going to 2. Then from 2 to 4. From 4 to 8. From 8 to 16. You can see that this very sequence does not have a common difference because their intervals are different. But you can realize that if I should pick the second one like 2 and divide by 1, I'll get 2. If I pick 4 and divide by 2, I'll get 2. If I pick 8 and divide by 4, I'll still get 2. If I take 16 and divide by 8, I'm going to get 2. Therefore, in this case, we see that the sequence has a common ratio, not difference. It has a common ratio. So if I should also take 32 and divide by 16, I will still get 2. If I pick 64, divide by 32, I'm going to get 2. Therefore, to get the next term, so for example 1, you have to multiply by 2 to get 2. Multiply 2 by 2 to get 4. Multiply 4 by 2 to get 8. Multiply 8 by 2 to get 16. So you have to also multiply 16 by 2 to get the next term, which is 32. Multiply 32 by 2 to get 64. Multiply 64 by 2 to get 128, and so on. Therefore, this becomes the next preceding terms. So it has a common ratio of 2. Now, anytime a sequence has a common difference, it means that that sequence is called an arithmetic progression. Arithmetic progression, or we call it an AP. Another name for an AP is a linear sequence. Then we also have, anytime you have a sequence with a common ratio, that sequence is also a geometric progression, or we call it an exponential sequence. So it means that I and II is an arithmetic progression, whereas the last one, III, is an exponential sequence or a geometric progression. Now let's look at these questions. Study each of the following examples and find the next four terms. So let's look at I. We have 1, 3, 6, 10, 15. So looking at this, let's first check. If I take 1 and 3, the difference is 2. If I take 3 and 6, the difference is 3. If I take 6 and 10, the difference is 4. If I take 10 and 15, the difference is 5. So you can see that this sequence doesn't have a common difference. Let us also divide and see. If I take 3 and divide by 1, I'll get a common ratio of 3. If I take 6 and divide by 3, I'll get a common ratio of 2. If I take 10 and divide by 6, it is still 10 over 6 or 5 over 3, which is also a different common ratio. So you realize that this question, this very sequence, does not have a common ratio and it doesn't have a common difference. Therefore, this sequence is neither an AP nor a GP. It means that it is taking a different form of a sequence. So let us study the sequence well to be able to come up with the rule. We have 1, 3, 6, 10, and 15. Now you can see that the difference between 1 and 3 will give us 2. The difference between 3 and 6 will give us 3. The difference between 6 and 10 will give us 4. The difference between 10 and 15 will give us 5. So you realize that the original sequence is not an AP, but the first difference, these values are called the first difference, rather forms an AP, because you can see that the first difference have a difference of 1, 1, 1, 1. So the first difference of this given sequence rather forms an AP. So what it means is that if I want to find the next terms, what do? The first one, we added 2 to 1 to get 3. We added 3 to 3 to get 6. We added 4 to 6 to get 10. We added 5 to 10 to get 15. So if I want to get the next value, remember, since this one is an AP, the next value will be 6, 7, 8, and so on. Therefore, if I want to get the next value, I have to take 6, add it to 15, then I will get 21 as my next, and I'll pick 7, add to 21, then I'm going to get 28. Then I'll also pick 8, add to 28, then I'll get 36. So and so on. It means that if I want to find the next value is going to be add 9 to 36. Then you will get 45 and so on. You will get 45 and so on. So that is how come we got these values. Alright. Now let's move on to the II. With the II, we have 1, 4, 7, 10. So 1, 4, 7, 10. Let's look at the difference. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus So you can see that this one has a common difference, therefore it is an arithmetic progression. Because we have a common difference of 3, it means we keep adding 3 to each term. So 10 plus 3 will give us 13. Then 13 plus 3 is 16. 16 plus 3 is 19. 19 plus 3 is 22. And so on. Now let's look at the third one. The third one, you can see that it is not having a common difference. Because 4 minus 2 will give us 2. 8 minus 4 will give us 4. 16 minus 8 will give us 8. So there is no common difference. But when I divide, 4 divided by 2 will give me 2. 8 divided by 4 is 2. 16 divided by 8 is 2. And so on. So you realize that when you multiply 2 by any preceding term, you are going to get the next term. So to get the next term, multiply 16 by 2 and you will get 32. Multiply 32 by 2, 64. Multiply by 2, 128, and so on. Good. Now the next one is 4, 2, 1, 1 on 2, 1 on 4. This is also a geometric progression. Why? Because if I divide 4 by 2, I'll get 2. If I divide 2 by 2, I'll get 1. If I divide 1 by 2, I'll get 1 on 2. If I divide 1 on 2 by 2, I'll get 1 on 4. So we keep dividing by 2. If you divide this by 2, 1 on 8, 1 on 16, 1 on 32, 1 on 64. Then it goes on and on. Therefore, the common ratio is 1 on 2. Our common ratio is 1 on 2, and it is a geometric progression. Then we have 2, 6, 12, 20, 30, and so on. Now this sequence is just like the first one. It is neither a geometric progression nor an arithmetic progression, because the sequence does not have a common ratio and it also doesn't have a common difference. But we can look at the difference of each. So for example, if I pick the difference of 2 and 6, I'll get 4. If I pick the difference of 6 and 12, I'm getting 6. The difference of 12 and 20, I'm getting 8. Difference of 20 and 30, I have 10. So you can see that their differences is rather forming an arithmetic progression, and this difference is called the first difference, and it is forming an arithmetic progression. Because the first differences are forming an arithmetic progression, to find the next term, what we have to do is pick this 12. Or let me start from here. You realize that we added 4 to 2 to get 6. We added 6 to 6 to get 12. We added 8 to 12 to get 20. We added 10 to 20 to get 30. Therefore, if I want to get the next value, add 12 to 30, and that is going to give us 42. Add 14 to 42. That will give us 56. Add 16 to 56, and that will give us 72. Add 18 to 72, and that will give us 90. So if I want to get the next value, what will I do? It means that I have to add 20 to 90, and that will give me the next value, which will be 110, and so on. So that is the rule for this sequence. Now, in this section, we shall be looking, or we will focus on linear sequence. I have already explained what a linear sequence is. Another name for a linear sequence is an arithmetic progression. It's an arithmetic progression. And we are saying that an arithmetic progression is a sequence in which each term is derived previous term by adding a constant. You add a constant, and that constant is called a common difference. That constant is called a common difference. The common difference can be a positive or a negative. So, an example is here. Looking at this sequence, we have 2, 5, 8. And you can see that there is a common difference of 3. Because to get the next term, you add 3 to 2 to get 5. To get the next term, add 3 to 5 to get 8. Therefore, if I want to get the next term, I'll add 3 to 8, then I'll get 11. Add 3 again, you have 14. Add 3, 17. Add 3, then you get 20. So that is a linear sequence or an arithmetic progression with a common difference of 3. Now let us derive the general term for an arithmetic progression. Deriving the general term for an arithmetic progression. Now let's say you have an arithmetic progression with the first term. When I write U1, it means the first term is A. Then what will be my second term, which is U2? It means that I need to add some constant to A. So let's say the constant is D. So I add A plus a constant D. That is the common difference to get my U2. If I want to get my U3, then I have to add A plus D. So the same second term, which is D, I add another D to it to get 2D. Then with my U4, I have to add another D to the U3. So I'm going to get A plus 3D. So I keep adding. U5 is going to be A plus, I add another D to this, I'll get 4D. So I keep adding till I'll get my last term, which is called UN. So my UN2, let's study the pattern. You realize that in each of the terms, the A is there. The A is there. So in my last term, there will still be an A plus. But you realize that the last terms keep changing. The first one was D. The first one, there was no D, there was nothing there. Then the D increased by 1. It keeps increasing 2, 3, 4. So what will be the value here? That is what we are going to look at. So when we study the pattern, you realize that when U was 1, we had plus 0D. 0D we don't write because 0 times D is the same as 0. Then when N was 1, we had 1D. When N was 3, we had 2D. When N was 4, we had 3D. When N was 5, we had 4D. So if we have N, then we will have what? It means that all the values here keeps reducing by 1. If we have 5, we get 4. If we have 4, we have 3. If we have 3, we have 2 here. So we keep reducing by 1. Therefore, if we have N, then we have to also get N minus 1D. And this is the general term for an arithmetic progression. So we have UN is equal to A plus N minus 1D, where A is the first term and D is the common difference. Alright, so we are done. Let's take note of this, the general term of an arithmetic progression. Now let's take this example. For each of the following linear sequences, AP, determine the 8th term and the nth term. So there are two things. We are to determine the 8th term, then we also determine the nth term. So let's start. The sequence is 16, 14, 12, 10. It continues. So let's see, it goes on and on. Now you can see that our first term is 16. Then let's look at the difference. 16 minus 14, or the difference is taken by this minus this. So 14 minus 16 is negative 2, or 12 minus 14 is negative 2, 10 minus 12 is negative 2. So it has a common difference of negative 2. Now, we are using the general term. Remember, this is the formula for the general term. So we just substitute the values. The question is asking us to find the 8th term. So 8th term means n is 8. So we substitute 8 here. Then we have a, which is 16 plus 8 minus 1, multiplying the common difference, which is negative 2. Then we can just simplify it to get the 8th term to be 2. That is simple. Now, the question says we should also find the nth term. So the general nth term is going to be, find the 8th term and the nth term. Okay, so it means that even here, I was supposed to find the nth term for the So now that we know our 8th term, if I want to find the nth term is going to be substituting the values of A and D into the question. So if I substitute the values into it, I'm going to get UN is going to be equal to, what is my A? My A is 2. Then plus n minus 1 times the D. And what is my D? The D in the question is negative 2. The D in the question is negative 2. Let me check whether I did it here. Okay. Alright. So I'll just substitute it inside and you simplify. When you simplify, that becomes your general term. So UN should be equal to 2 plus negative 2 times n is negative 2n. Negative 2n. Then plus 2. Then 2 plus 2 is 4. So I'm going to get UN is equal to 4 minus 2n. So this value becomes the general term of this sequence, or the nth term. Another name is the nth term. So that is the answer. Or the question is asking us to find the 8th term and also the nth term. So the nth term is this value. We got this value by substituting A, which is 16, and D, which is negative 2, into the general formula, this one. And by simplifying, you will get this. Now let's come to II. The II, our sequence is this. So we have them here. Here too, our first term is 6. Then our common difference is going to be this minus this, which is negative 4. So let us still apply the formula, which is UN is equal to A plus n minus 1D. Substitute the values into it. Our A is 6. We are finding the 8th term. So n is 8 minus 1. Then multiplying the common difference, which is negative 4. So by simplifying this, we will get our 8th term to be negative 22. Now we also need to find the general term, or the nth term. To find the nth term, substitute this value. Substitute A, which is 6, and D, which is negative 4, into the general term. So we have UN is equal equal to a, which is 6, then plus n minus 1 multiplying by d, which is negative 4. Then we can simplify. So un, let me simplify it here. Un is equal to 6. Then we expand. So negative 4 n, then negative is positive 4. So we have un to be equal to 10 minus 4n, and that is your nth term. So this becomes your nth term. Alright. So because this is your nth term, if you want to solve, for example, if n is 1, when you put 1 there, you get 10 minus 4, then you get 6. If n is 2, you get negative 8 here. So 10 minus 8 is 2. Then it goes on like that. So this becomes the general term or the nth term of the sequence. Now let's move on to example 2. The third term of an AP is negative 1. And the 10th term is 20. So there are two statements here. The third term of the AP is negative 1. So the third term of an AP is negative 1 means U3, that is your third term, is equal to negative 1. But what is the general term? The general term of the AP is A plus n minus 1 d. This is your general term. So if n is 3, that's the third term. You substitute 3 there. So you are going to get third term is a plus 3 minus 1d, and it is equal to negative 1. Then we simplify to be a plus 2d is equal to negative 1. That gives us equation 1. Then the second statement is the 10th term is 20. 10th term is 20. So the 10th term is 20 is also going to be U10, which is equal to 20. But what is U10? You substitute 10 into the general term, and that will give us a plus 10 minus 1d equal to 20. So we have a plus 9d equal to 20, and that is your equation 2. Now you need to solve the two equations simultaneously. You can either use a substitution method or the elimination method. I was using elimination method here. So I am subtracting equation 1 from equation 2. A minus a goes away. 9 minus 2 becomes 7d, and 10 minus negative 1 is 21. Dividing through by 7, we have 3. We have 3. So that is going to be our common difference. Now we can substitute this common difference into either equation 1 or 2. I substituted it into equation 1. And by simplifying, my first term a is negative 7. So that is the solution to this question. Now, remember the question is asking us to find the 20th term and the general term. So, what do? It means that we already know that our first term is negative 7 and our common difference is 3. So, to find the 20th term, it means we are finding U20. And U20 becomes a plus n minus 1. So, 20 minus 1 will be 19d. Then our a is negative 7 and our d is 3. So substituting it inside and simplifying, you have our 20th term to be 50. Now the question also is asking us to find the general nth term of the sequence. We know that the general formula for an AP is this. So our a is negative 7 and the common difference is 3. So we can expand. 3 times n will give us 3n, and 3 times negative 1 is negative 3. So negative 7 minus 3 gives us negative 10 plus the 3n. So our un is going to be equal to 3n minus 10. And that is the nth term of the sequence. Alright, so let us move on to the next example, which is example 3. A fifth term of an AP is thrice the second term. So let's take note. The fifth term is thrice the second term. So fifth term is 3 times second term. That is my first equation. So the question is, what is the formula for fifth term? The fifth term of an AP is giving us a plus 4d. Remember, it is n minus 1d, but n is 5. So 5 minus 1 is 4d. Then here we have 3 as a constant out. Then into bracket, your second term, twice the second term, thrice the second term. So your second term is going to be a plus n minus 1. 2 minus 1 is 1. So 1d, which is the same as d. So this is my second term. Now we can expand. 3 times a is 3a, 3 times d is 3d. Then we group like terms. When we group like terms, we are going to get d is equal to 2a. So this is equation 1. Now the next statement is, if the first term is 8, so first term is 8. What is my first term? My first term is 8. So u1 is 8. Now we know that u1 is the same as a. So a is equal to 8. Then that becomes equation 2. What do I have to do? Substitute this equation 2 into equation 1. So go to equation 2. Go to equation 1. Wherever you see a as your first term, put in 8. So that is what I have just done here. D is equal to 2 times 8, and D is 16. Therefore, I know that my first term is 8, and my common difference is 16. So the question says, find the nth term of the sequence. The nth term formula is given as this. So what you need to do is to substitute a, which is 8, and substitute d, which is 16. Then you simplify by multiplying. 16 times n is 16n. 16 times 1 is 16. Then add 8 and negative 16. You will get negative 8. So we have 16n minus 8 as the general nth term. Now the last part is to find the 10th term. So to find the 10th term, what you have to do is to substitute 10 into or in replace of n, and that is what I have done here. So when you do that, you have u10 to be equal to 10 times 16. That is 160 minus 8, and the final answer is 152. That is your 10th term. In this section, we shall be looking at recursive sequence. When we talk of recursive sequence, it is a type of sequence. The sequence can be either an arithmetic progression or it can be a geometric progression. But in this case, the formula is explicitly defined. Now remember that under geometric progression, the formula can be in the form un is equal to a plus n minus 1d. In this formula, before you can find the nth term, you need your first term. You also need a common difference before you can do that. But in the recursive form, so this is going to be the recursive form. In the recursive form, what you need to do is the formula will be defined for you in an explicit form. So, for example, they will just give you, for example, n minus 1 or 2 into bracket n minus 1. Here you don't need any first term. The only thing is that once you know your successive terms, you can just use it to compute the remaining terms. For example, if I say n is equal to 1, I will just substitute it here. Then I will get 0. If n is equal to 2, I will just put 2 inside. Then I will get 2. If n is equal to 3, 3 minus 1 is 2. 2 times 2 is 4. So you can see that I can form the sequence even without first knowing my common difference or my first term. So whenever the formula is in this form, then that is just the general explicit form. But in the recursive formula, we don't use the a, we can find the d, but we only define the formula based on, let's say, you will be given u1. So once you know your u1 or your first term, you keep substituting the values of n and your first term into it to get the sequence. So the most important thing here is to know that whenever a sequence is in a recursive form, there are two things there. You need the number of terms. This un minus 1 is called the term or the preceding term. Un minus 1 means the preceding term. So for example, if I want to find third term, which is u3, I must know u3 minus 1, which is u2. That is the second term. If I want to find the fifth term, u5, I must know u5 minus 1, which is the fourth term. So anytime a sequence is defined in such a way that you can find the next term by knowing the preceding term, then that formula is called a recursive formula. That formula is called a recursive formula. So let us pick an example. Alright, let's start from example 1. Write the recursive formula for the sequence 6, 8, 10, 12. Now, to write the recursive formula for this, first of all, we need to determine the common difference. We need to determine the common difference. The common difference is given by 8 minus 6, and which is 2. So now we know the common difference to be this. So as I said, we want to find the general term, which is un. But before we find the general term un, for a recursive formula, we must look for the next term before this un, and that term is called un minus 1. So once we know the preceding term, which is un minus 1, we only have to add the common difference to it. Then we will get un. So this is the general recursive form for an arithmetic progression. So the general term is un minus 1 plus d, where un minus 1 is the preceding term. Preceding term means that if I am looking for, let's say, the 7th term, I must know the 6th term. Or if I am looking for the 2nd term, I must know the 1st term. So now in this question, looking at the sequence here, you can see that I know my first term to be 6. So my first term is 6. Because I know my first term to be 6, I can find the 2nd term. So if I am finding the 2nd term, then the u1 becomes my preceding term. Is that right? So for example, if I want to find un is going to be un minus 1 plus the common difference. That's the general formula. So the common difference is 2. But I know a preceding term, which is u1 to be 6. In the question, you can see that the first term is 6. So since I know u1 to be 6, if I want to find, for example, u2, I'll just put n is equal to 2 2 minus 1 will be u1. Then all this becomes u1. And once it is u1, I'll substitute 6 there. Then 6 plus 2 becomes what? 8. Then that becomes my u2. So the recursive formula for this sequence becomes un is equal to un minus 1 plus 2. So this is the general term. But because the common difference of the sequence is 2, we only substitute 2 there. Then anytime you are defining a recursive formula, you define it using the first term, which is always the preceding term. Alright. Now let's take the next example. Write the recursive formula for the sequence. So this is the sequence. The first thing you need to do is to quote the general formula, which is un is equal to un minus 1 plus d. But in this case, our u1 is 1. So u1 is equal to 1. So if I want to write it, first of all, find the common difference. The common difference is negative 3 minus 1, and that is negative 4. Then you now substitute it here. So we are going to get un is equal to un minus 1 minus 4, where u1 is equal to 1. So this gives us the recursive formula. That's the recursive formula. Now let's move on. There is another example, example 3. Find the sixth term. Now this time, they have rather given us the recursive formula. Our recursive formula is this. And they have given us the preceding term. That is our first term to be u1. And we are supposed to find the sixth term. So what do? Because the preceding term is u1, it means that we can start finding the second term, because we know the first term. So the term we can find first is u2. And once we get u2, we can also use u2 to find u3 and so on. So we'll start by finding n is equal to 2. If n is equal to 2, then it means we are finding u2. So u2 is equal to u1 plus 5. Why is it u1? Remember that the form here is n minus 1. So if I substitute 2 here, I also put 2 here, and 2 minus 1 becomes what? 1. So u1 plus 5. But what is u1? u1 is 2. So put 2 here. So 2 plus 5, then we get 7. Therefore, my u2 is 7. Now I know u2, so I can also find u3 by letting n be equal to 3. If n is 3, and it means I'm finding u3. So u3 means wherever I see n in the formula, I'll put 3 there. So 3 minus 1 plus 5. Then 3 minus 1 is 2 plus 5. But what is u2? u2 is 7. So you put 7 there plus 5. Then you will get 12. Now I know u3, so we can also find n is equal to 4, which is u4. u4 means put 4 here. 4 minus 1 plus 5. Then 4 minus 1 is u3 plus 5. But we know that u3 is 12. So 12 plus 5, that gives us u4, which is 17. Now we know u4 to be 17, so we can also find u5 by letting n be equal to 5. Therefore u5 is going to be put 5 in the general formula. N is 5, so 5 minus 1 plus 5. Then we have u5 to be equal to u5 minus 1 is 4 plus 5. Then we have u4, which is 17. So 17 plus 5, which is 22. Then finally, the question is asking us to find the sixth term. So n is equal to 6. We have u6. So u6 should be equal to 6 minus 1, which is going to be plus 5. So we have u6 to be equal to u5 plus 5. But what is u5? u5 is 22. So substitute 22 there plus the 5. and we have U6 to be 27. Therefore, we are saying that the sixth term is 27. The sixth term is 27. Now, let's welcome back to exponential sequence. An exponential sequence, as I said, is the same as a geometric progression. GP is a sequence in which each term is a constant multiple of the preceding term. So what it means is that, now let's say you have the first term of a geometric progression to be 2. That is, U1 is equal to 2. Then, if I keep multiplying by some constant R is equal to 2, so let's say 2 times 2 will give me my second term, which is 4. Then I multiply by 2 again to get 8. Multiply by 2 again to get 16. So you can see that it will have a common ratio of 2, because if I take the second term, U2, and divide by the first term, I'll get 2. Or if I take U3 and divide by U2, I'll still get 2. Or even pick U4 and divide by U3, you get 2. So whenever you see a sequence in that form, and it means that that sequence is an exponential sequence. So now let's say you have your first term of a GP. You have your first term of a GP, U1, to be equal to A. Then it means that if I want to find my U2, I must multiply the A by some constant, which is the common ratio R. So if I multiply A by R, I'm going to get A multiplied by R. And we know that R is the same as R to the power 1. Now if I want to find my third term, then I have to multiply AR, which is the second term, by R again. If I multiply by R again, I'll get RA times R squared. So my third term becomes AR squared. If I want to find U4, that's the fourth term, then I have to multiply this by another R. Then I'll get AR cubed. So I have AR cubed. Then again, it can continue like that. By multiplying by R again, I'll get U5 to be equal to AR exponent 4. So I have I have U5 to be equal to AR to the power 4. So looking at a pattern, it can continue up to where I'll get my nth term. Un is equal to, now you realize that the A's are constants. The A's are constants. So my nth term will still have A. That's the first term. Then all of them. Now remember, the first term here is also R to the power 0. R to the power 0 is the same as 1. So normally we don't write it. But where you need to take note is the 1. When we have a first term 1, here becomes 0. 0 means 0 means 1 minus 1. When we have 2 here, we have 1 here. 1 means that these 2 minus this 1. So where we have 3 here, we are getting 2 here. 2 means 3 minus 1. Where we have 4 here, we have 3 here. This 3 means that 4 minus 1. Where we have 5 here, we have 4 here. 4 means that 5 minus 1. Therefore, where we have n here, we must also get r to the power n minus 1. And that becomes the general term of the expression, the general term, the nth term of a GP, nth term of GP. So that is the general term of a geometric progression. Un is equal to ARn minus 1, where A is the first term and R is the common ratio. Now n is the number of terms. N is the number of terms. So let us pick our first example. Under example 1, we are to find the 5th term of the GP. So this is the GP, which is 3, 6, 12, and so on. Now, this is a GP in the sense that if I divide 6 by 3, I will get 2. If I divide 12 by 6, I'll still get 2. Therefore, my common ratio is 2. And the first term is 3. So I have A to be 3, and I have my common ratio to be 2. Then the nth term formula is this. So what we need to do is to substitute A there, then we also substitute R there. Then the question is asking us to find the 15th term. Therefore, our n will also be 15. So A is 3, R is 2, and n is 15. Then we solve. This one is just multiplication. It's a multiplication sign. So we have U15 should be equal to 3 times 2 to the power 15 minus 1 is 14. And when we multiply everything, that is the answer. So it means that our 15th term is going to be 2949152. That is the solution. Now the next example, example 2. We are to find the nth term of the sequence. The nth term of the sequence whose first term is 36 and the fourth term is 4. So the question says that first term is 36. So this statement, first term is 36, means that U1 is equal to 36 and fourth term is 4. So it means that U4 is 4. But the question is, we already know that U1 is the first term, so A is 36. Then U4. So we substitute 4 into the general formula. We know that the general formula is UN is equal to ARN minus 1. So when we put 4 here, that is for the n, we are going to get, well, I think there is a mistake with the solution here. There's a mistake with the solution. I used a GP. I used a sequence. Now, since we are dealing with geometric progression, all the solution here is arithmetic progression. So that is wrong. Let me solve it again for you. Let's take our time and solve it together. Solution. Remember, the sequence, we are assuming that the sequence here is GP, even though the question never stated it. But we assume that it is GP because we are dealing with GP. But if it were to be an exams question, they will specify the type of sequence. So they may say that find the nth term of the exponential sequence, because we are dealing with the subtopic exponential sequence. So it means that my general term un is going to be ar n minus 1. So the first statement is saying that the first term is 36. So still we have a to be 36. That is my first term. And the fourth term is 4. So my fourth term becomes u4. u4 becomes ar, so I'll put 4 here, and I'll get 4 minus 1. So my u4 becomes ar exponent 3. But we know our first term to be 36, we know our fourth term to be 4. So what do we do? So what we need to do is to equate. Since our first term is known, that is perfect. But we need to look for the fourth term. The fourth term is 4. So the statement fourth term is 4 means u4 is equal to 4. Therefore, we are going to equate the fourth term, which is this, to 4. So this implies that ar exponent 3 is equal to 4. But we know a to be equal to what? 36. So we substitute that inside. We have 36 r to the power 3 should be equal to 4. And we can divide through by 36. So we have r cubed should be equal to 4 on 36. So we have r cubed should be equal to 1 on 9. I believe so. Let me check that. 4 divided by 36. That's 1 on 9. So we can now find our r by taking the cubic root of both sides. The cubic root of both sides. Then we have r to be equal to 1 over the cubic root. So the cubic root of 9. So that becomes the answer. 1 divided by, or let me see, 1 on 9, all exponents all exponents 1 on 3. Okay, so that is the answer. That would be our common ratio. The question is asking us to find the nth term. So because we are finding the nth term, now there is a problem with the question. Now remember that there is 1 over 2 here. I think the value is supposed to be 4 whole number 1 over 2. So the fourth term is 4 whole number 1 over 2. So let us correct that and resolve it. So let's start all again. The question says that the first term is 36. Remember, we are dealing with GP. So the first term is 36. We have a to be 36. And we have the fourth term. The fourth term is 4 whole number 1 over 2. So that is going to be this. Fourth term is AR to the power 4 minus 1, which is 3, should be equal to 4 whole number 1 over 2. So we know that 4 whole number 1 over 2 is the same as 9 over 2. So AR cubed should be equal to 9 on 2. But we know our first term to be 36, so we substituted there. Then we also know, so that is it. So we are going to get 36 R cubed should be equal to 9 on 2. Now I want to make R cubed stand alone, so I'll multiply through by 1 over 36. Then I'll also multiply here by 1 over 36, so that the 36 can cancel the 36 here. Then 9 can also goes into 36, 4. 4 times 2 will be 8. So I have R cubed is equal to 1 on 8. Then we know that 8 is the same as 2 to the power 3. The 1 is also the same as to the power 3. Any number to the 1 to the power any number is the same as 1. Therefore, we can just put them together as 1 on 2, all exponent 3. Then using the power rule of indices, since the powers are the same, we can cancel it and equate the bases. Therefore, R is equal to 1 on 2. Now the question is asking us to find the nth term. Because we are finding the nth term, you have to quote the nth term formula for a GP. Then you substitute A and R into it. So A is 36 from the question, and R is 1 on 2. That is this. You can leave your answer here, but if you are very good in indices, then you can further simplify it. We know that 36 can be written as 9 times 2, 9 times 4, and 4 is the same as 2 squared. Then times this 1 over 2. The 1 over 2 can be written as 2 exponent negative 1. Then all exponents, the n minus 1, which is here. Now I will let the 9 stand alone. These 2 and these 2, they are the same basis. Because they are the same basis, I'll just take 1. Then I'll add the exponent 2 plus negative 1 into bracket n minus 1. So that is what I have added here. So we still have 9 into bracket 2. You add 2 plus 1 will give us 3, then minus n. So the final nth term formula becomes this. So this is the final answer. That is the final answer. However, if you leave your answer here, it is still correct. But this is more simplified. Okay. Now let's move on to example 3. We are to find the number of terms in the exponential sequence. So our exponential sequence is 1, 1 on 3, 1 on 9, and 1 on 2, 4, 3. So quickly we know that our first term is A. A is equal to 1. Then how do we find the common ratio? The common ratio is the second term divided by the first term. So 1 on 3 divided by 1 will still give us 1 on 3. Or you can use the second term and the third term over the second term. You will still get 1 on 3. Therefore, our common ratio is 1 on 3. Now what we need to do is to substitute these values into the nth term formula. The question is asking us to find the number of terms. But remember that in this sequence, the last value is this. This last value is called the UN, or the last term. So you can see that UN, which is the nth term, has been given to be this. So because we know the nth term, it means that in the sequence we know the first term, we know the last term. So A is 1 and UN is this. So let's substitute it into the general formula. It means that UN is 1 on 2, 4, 3. Then my A is the first term, which is 1. The common ratio is 1 on 3. Then exponent n minus 1. Now we need to simplify and find n. So what we do is that 2, 4, 3 can be written in the terms of indices as 3 to the power 5. 3 to the power 5 should be equal to 1 times any number is the same number. So we still have 1 on 3, n minus 1. Then 1 on 3 on 5 can be written as 1 on 3 all to the power 5. Then should be equal to 1 on 3 exponent n minus 1. Since the bases are the same, we can cancel that and equate the exponents. So we say that 5 is equal to n minus 1. And by simplifying, we will have n to be 6. Therefore, the number of terms is 6. Or there are 6 terms in the exponential sequence. Now, let's look at the recursive formula for geometric sequence. Recall that under the recursive formula for arithmetic progression, we said that UN is given as UN minus 1, then plus D, where the UN minus 1 is the preceding term and D is the common difference. Now we are going to do the same thing for a geometric progression. In geometric progression, if you are also writing a recursive formula, we need the preceding term. So let's say we want to find UN, the nth term for a geometric progression. We still need the preceding term, which is called UN minus 1. But this time we don't add to a common difference. No. What we do is that we multiply the preceding term by a common ratio. And once you multiply by a common ratio, then if you know your preceding term to be, let's say, U1, your first term, to be A, then we can use this definition to find the remaining sequences. We can use this to find the remaining sequences. So for example, if I give you the first term of a sequence to be, let's say, 1, the first term of a sequence to be, let's say, 1, then I give you a preceding term. Let's say my nth term is given as, let's say 1 over 3 u n minus 1. Then from this, I can find the remaining terms, because now let's say I've given you my first term. So let's start with n. When we start with n, it means that since I know my first term, let's say my un minus 1, or let's say my u1, I'm coming. Let me define it well. So let's say you have been given, let's use this example here. Let's say you have a sequence. This is a geometric progression. So there's a nice example here. We can find our common ratio from this sequence. The common ratio is 2. So this is my common ratio. Now after you have this common ratio, what you need to do is multiply this common ratio by any preceding term. What it means is that if I want to find u2, that is 6, what do? I have to multiply the preceding term of u2 is going to be u1. So I'll multiply u1 by the common ratio, which is 3. If I want to find u4, which is 24, I have to multiply the common ratio by u3, which becomes the preceding term of u4. So that is what we call the recursive formula. So now in this example, if we want to find the recursive formula, we are going to say that the recursive formula is given by un is equal to r multiplying un minus 1, where u1 is equal to 3. So we need u1 to be able to find it. So this is how a recursive formula is written for a geometric progression. So it means that if I want to find, let's say, u2, I'll just put 2 here to get, already remember I know my common ratio to be this, so I'll just substitute 2 as my common ratio, then u2 minus 1. So I'm going to get u2 to be equal to 2 u1. 2 minus 1 will give me u1, but I know u1 to be 3, so I'll just substitute that there as 2 multiplying 3. Then I'll get 6, which is correct. So this is how to write the recursive formula for a geometric progression. It is written in this form, run minus 1. So let us pick an example for clarity. Let's take this example, example 2. Find the 16th term un is equal to 3.5 un minus 1. So here you can see that in the recursive formula there is 3.5 here. The recursive formula is given as un is equal to r un minus 1. So you can see that the r is the 3.5. So by comparing, we see that r is equal to 3.5. That is our common ratio, but we don't even need that one. The most important thing is we need to find the 16th term. So finding the 16th term means that we are finding u16, and u16 means wherever I see n in the recursive formula, I'll put 16 there. So when I put 16 inside, I'm going to get 3.5 u 16 minus 1 will give me u15. It will give me u15. But we see that u15 is 21. So we substitute that here. Then we are going to get u16. That is the 16th term to be this. That is the recursive formula for a geometric progression. Now let's take example 3. Now these are problems related to recursive sequence. Let us look at example 1 of this. Given that u1, our first term is 1, then our nth term is given by the formula n un minus 1. The question is asking us to find u1, u2, u3, u4, and u5. So let us start. We have been given our first term in the question, and we have been given the nth term, which has been defined recursively. So let us start. Since we already know u1, we will start with u2. So u2 means wherever you see n, put 2 there. So we have here, we put 2 there to get u2. Then we put 2 here to get 2. Then u2 minus 1. So 2 minus 1. we are going to have u2 should be equal to 2. 2 minus 1 is u1. Then we can see that u1 is 1. So we substitute that inside. Then we have u2 to be 2. Now we know u2 to be 2, so we can also find u3 by still substituting it inside. So by substituting it inside, u3 means we are substituting it inside this formula. So it's supposed to be u3 should be equal to, there is a slight mistake here. Let us correct it. Now, so to find u3 means that we are going to substitute n for 3. So we have u3 should be equal to, wherever you see n, put 3 there. So 3 u, we still put 3 here. So 3 minus 1. So we have u3 to be equal to 3, then u2. So u3 should be equal to 3 multiplying u2. But we know that u2 is 2 here, so times 2. And the final answer will be 6. So our u3 is supposed to be 6. Our u3 is supposed to be 6. Now let's move on to the next value. So we are finding u4. So it means that all the solutions are wrong. Let's clean it and correct it. All the solutions are wrong. Okay. So the next one is going to be u4. So let's find u4. u4 means when I come to the formula, this formula, wherever I see n, I'm going to put 4 there. So it's going to be u4 should be equal to 4 u4 minus 1. Then I have u4 to be equal to 4 multiplying u3. But we know u3 to be 6. So we have u4 to be equal to 4 times 6. And that will give me 24. So that is for the u4. Now let's move on to u5. u5 also means that wherever you see n, put in 5. So we are going to get u5 should be equal to 5 u5 minus 1. And we will get u5 to be equal to 5 multiplying u4. But what is u4? u4 is 24. So u5 should be equal to 5 times 24. And we have 5 times 24 is what? 5 times 24 is giving us 120. Gives us 120. Then let's find the last one. Okay, the question said we should solve it up to u5. So we are done. Now let's look at the sequence. It means that my u1 was 1. My u1 was 1. My u2 was 2. My u3 is 6. My u4 is 24. And my u5 is 120. Now, the question says that describe the sequence of un. So let me go to a new page so that we will look at how to describe the sequence. Now we have un to be equal to 1 first, 2, 6. What was the next one? The next one, let me come here. The next one is 24 and 120. 24 and 120. So it goes on like that. So it means that my un can be written as, the first one is 1 factorial. Or let me put it this way for you so that you understand. The first one can be written as 1. The second one can be written as 2 times 1. Is that right? The third one can be written as 3 times 2 times 1. The fourth one can be written as 4 times 3 times 2 times 1. Then the last one can also be written as 5 times 4 times 3 times 2 times 1. So you can see that if n is 1, we have 1. If n is 2, we have 2 times 1. If n is 3, we have 3 times 2 times 1. If n is 4, we have 4 times 3 times 2 times 1. And if n is 5, we have 5 times 4 times 3 times 2 times 1. Now this value is called 1 factorial. This is called 2 factorial. This is called 3 factorial. This is called 4 factorial. This is called 5 factorial. Therefore, if I want to find the first term, it's just 1 factorial. If I want to find the second term, it's just 2 factorial. The third term is 3 factorial. Fourth term is 4 factorial. Fifth term is 5 factorial. So if I tell you to find the sixth term, it will just be 6 factorial. Therefore, we can conclude that the nth term, which is un, is given by n factorial. And that is the definition. Now let's end this section with example 2. Write down the first 5 terms of the following recursively defined sequence. Now we have un is 1, u2 is 1, then we have un plus 2. If un plus 2 is equal to un plus 1, then we are going to use this definition to find the sequence. So let's start. We will start with n is equal to 1. If n is equal to 1, what we are going to do is that we substitute it into this formula. We are substituting every value into this. So if n is equal to 1, we substitute it, n here, n is going to be here, so we have 1 plus 2, then there is another n here, so we will put 1 there, u1 plus 1 plus 1, and that gives you u1 plus 1. So we are going to get 1 plus 1 here is u3 should be equal to u1 plus u2. But you can see that u1 has already been given in the question. What is u1? That is, u1 is the same as, when you put 1 inside, you get u1 to be 1. So our u1 is 1. And our u2 here is going to be 1 again. So we have 1 plus 1, which is 2. So that gives us our third term. Let's go to if n is equal to 2. If we let n is equal to 2, wherever you see n in this formula, put 2 there. So when you put 2 there, you are going to get 2 plus 2, then u2, then u2 plus 1. So we have it here. then u2 plus 2 is u4, then u2 plus u2 plus 1 is u3. So u4 is going to be u2. What is u2? u2 is already in the question as 1. Then u3 has been, this is what we just find, u3 is 2, so we also put 2 here. Then 1 plus 2 will give us 3. So u4 is 3. Now let's go to where n is equal to 3. Let's go to where n is equal to 3. If n is equal to 3, we are still putting in the formula. This is the formula, un plus 1 is equal to un plus 1. So substitute 3 inside. 3 plus 2 then should be equal to, put 3 there, u3 plus 3 plus 1. So we have u5 should be equal to u3 plus u4. What is u3? You can see that u3 is 2 here. So we will put it there. Then what is u4? We got u4 from here, which is 3. So we also put it there. Then 2 plus 3 is 5. Now we have gotten all the terms. Remember in the question, when n is 1, you have u1 to be 1. So u1 is 1. Then u2 is in the question, 1. Then we have u3. u3 is 2. So you put 2 there. u4 is 3, which is 3 here. Then our u5 is 5, which is also here. Now the question says that we should also describe, or we should describe what sequence is it. So what type of sequence is this? Now you can see that this sequence doesn't have a common ratio. It doesn't also have a common difference. But you can see that when I add the first 2 terms, I'll get the second one, the third one. If I add these 2, I'll get 3. If I add these 2, I'll get 5. So what it means is that if I should also add the next 2, I have to get the next one. That's how the sequence is. Whenever you see a sequence in that form, we call that sequence a Fibonacci sequence. Let's take note of that. Let's take note of that. So for example, 1. Every Fibonacci sequence starts with 1, then another 1. Then you add the 2 to get 2. Add these 2 to get 3. Then add these 2 to get 5. Add these 2, so you get 8. Add these 2, you get what? 13. Then it goes on like that. Whenever you see a sequence of this form, it is called a Fibonacci sequence. So this brings us to the end of this section in this video. We shall continue in our next video, or in our next lesson, from the sum of an AP, how to find the sum of an AP and also the sum of a GP. Then we can move on to other concepts under sequence and series. Thank you very much. Bye bye.